This is my laboratory. I'm researching a new mechanism for a truck.
Professor, there's a message for you.
Ah, a message. I'm having trouble with customers who know a lot about mechanics. How can I deal with this kind of customer and earn their trust? You know, I actually get this kind of question a lot. I think a lot of you say you aren't good with mechanically inclined customers.
With this vehicle, there's no difference between a diesel engine and a gasoline engine.
What? Don't you even know the difference between a diesel engine and a gasoline engine?
A diesel engine is more fuel efficient, so I think it's more economical than a gasoline engine.
Yeah. I could have told you that. I bet there are some customers around you that are really mechanically savvy. We call a customer like this a mechanical whiz. Not a bad nickname if I do say so myself. That's right. How do you deal with a mechanical whiz? The answer is actually pretty easy. All you have to do is become even more knowledgeable than they are. So, in order to do that, we need to study mechanics in depth. Aha! You know that most truck engines are diesel engines. Now I want you to understand diesel engines completely. Most of you who have standard driver's licenses will pretty much understand how gasoline engines work. So let's start with how diesel engines differ from gasoline engines.
This is the inline six-cylinder engine. The cylinders are lined up, so it is called an inline engine. There is also a four-cylinder version. This is the V8 engine. There are four cylinders on the right and four on the left. They look like a V when viewed from the front, so it's called a V engine. There is also a 10-cylinder version.
That's the powerful Mitsubishi Fuso diesel engine lineup.
That's impressive, but they look just like gasoline engines. How are they different?
The operation is different.
The operation?
That's right. Now let's review engine operation.
Let's take a look at four-stroke cycle engine operation. Intake stroke. When the piston descends from the top dead center position, the intake valve opens and a mixture of vaporized gasoline and air is drawn in. Compression stroke. The valve closes and the piston moves up, compressing the air-fuel mixture that was drawn in. Power stroke. Right after compression, the spark plug produces a spark, causing the air-fuel mixture to explode. That force drives the piston down. The downward force of the power stroke turns the crankshaft, giving power to the engine. Exhaust stroke. Just as the piston starts to move up again, the exhaust valve opens, pushing out the burned exhaust gas. After this exhaust stroke, the operation repeats itself, continuing to power the engine.
So, do you remember now?
Yes.
Take a look over here. The intake, compression, power, and exhaust make up the four operations of the piston in the four-stroke cycle engine. Engines where the piston only cycles through 2 operations are called 2-stroke cycle engines.
That means diesel engines also go through intake, compression, power, and exhaust.
Exactly. So then, what's the difference?
Let's compare the operation of diesel engines and gasoline engines. First is the intake stroke. Gasoline engines take in an approximate mix of gasoline and air, but a diesel engine only takes in air. This is the big difference. In the compression stroke, as the piston moves back up to the upper dead center, look at the opening in the cylinder head. Diesel engines are quite narrow, so the compression ratio is much higher than that of gasoline engines. Gasoline engines are designed for a compression ratio of around 20.
During the intake stroke at the lower dead center position, the volume of the air is compressed down to 1/20th. When the pressure reaches between 50 and 70 hectopascals, the temperature gets as high as 500 to 700 degrees Celsius.
In the power stroke in gasoline engines, the compressed air-fuel mixture is ignited by the spark plug. In diesel engines, the highly compressed air becomes as hot as 500 to 700 degrees Celsius, and diesel oil is injected into the cylinder, igniting immediately upon contact with the hot air. This expanding force pushes the piston. Gasoline and diesel engines are the same in the exhaust stroke.
This is a summary of the difference in operation. Gasoline engines first mix air and fuel, then take in and compress them, igniting with a spark. Diesel engines take in air and compress it to a high temperature before injecting fuel that self-ignites. These are major differences.
This is the inline 6-cylinder engine 6M60T1. The total emission is 7.545 liters, turbocharged for a net 240 horsepower. The fuel injection pump is coupled with the crankshaft. Fuel is injected into the cylinder under high pressure.
Now we'll use this nozzle tester to make sure the injection nozzle is operating properly.
Okay, but why do we test it?
The fuel injection pump must make various subtle movements to properly burn fuel under extremely high pressure. This apparatus is the heart of the diesel engine.
So this injection nozzle needs to have a high degree of accuracy.
Exactly. Ready?
Yes.
Switch on!
Wow, amazing!
Can you see? The fuel is injected strongly.
But Professor, why can't the fuel injection pump inject diesel fuel instead of gasoline?
I'd like all of you to think about that. Let's get back to the lab.
Yes.
This is a comparison of diesel fuel and gasoline. Diesel fuel has a lower ignition point, and gasoline can be ignited more easily. Diesel will spontaneously ignite as the temperature increases, and flame will ignite gasoline more easily. Diesel fuel prices are lower than gasoline, so it is more economical.
Ah, right. Diesel engines have a lower running cost. But isn't the initial cost higher?
Is that so?
Yes, some customers are like this. If a customer tells you that, you can answer like this.
The compression ratio, compression pressure, and explosive pressure are all higher in diesel engines, so they need to be more durable. Thus, the weight of the engine increases with the power output. The necessity of elaborate parts, such as the injection pump, make the overall manufacturing cost higher. Also, diesel engines have the demerit of being louder and vibrating more than gasoline engines.
The high compression ratio means the expansion is also larger, creating more powerful torque. Diesel engines are heat efficient, which means a high rate of the energy generated is used effectively. This is a significant advantage.
Diesel engines have high heat efficiency and thus lower fuel consumption. In addition, diesel fuel is less expensive than gasoline, so the operating cost is greatly reduced. Also, diesel engines don't need a spark plug or other device directly affecting engine performance. The injection pump is very reliable, and normal maintenance is relatively simple.
I'm concerned about the environment. Is anything being done about exhaust emissions?
Well, as for that, just a minute. People ask about the exhaust emissions. What measures are being taken to limit exhaust emissions?
What do you think?
As I've told you, diesel engines burn diesel fuel with a sufficient amount of air at a high temperature. So the makeup of the exhaust emissions is different from gasoline engines. In particular, nitrogen oxide and black smoke are difficult to reduce at the same time. However, we are doing everything possible to improve this and taking measures to limit exhaust emissions.
So then that's okay.
Of course. So now you understand the basic characteristics of a diesel engine. Diesel engines have direct injection, right?
Yes.
What is better about direct injection type engines?
You'd like to know the merits?
Yes. What's wrong? Are you feeling sick?
Questions like this really put you in a bind.
I'll explain about the various types and structures of diesel engines, so you never find yourself in this situation. Watch this. This is a view into the inside of a cylinder where fuel is injected. Vaporized fuel mixes with air and is then ignited. Though this all happens in a moment, it does take some time.
This is a graph of the time leading up to ignition. If the fuel lights quickly, it means that it is ignited right after injection, which results in smoother combustion. On the other hand, if the fuel takes longer to ignite after injection, it burns all at once. This increases the pressure, sending a shock wave through the cylinder and piston that causes a knocking noise.
That's called diesel knock. It happens a lot when starting a cold engine.
Diesel knock doesn't just make noise, it's also bad for the engine, right?
Yes, but don't worry. Now very few engines produce diesel knock. Let's move on to the next topic. Diesel engines are divided into 3 categories based on the shape of the combustion chamber: direct injection type, pre-combustion chamber type, and swirl chamber type. Let's see the characteristics of each.
In the direct injection type, the cylinder has a flat surface and the piston has an indentation on its crown. This indentation causes a swirling motion in the air during the compression stroke. The injection nozzle has 5 or 6 holes through which it sprays fuel in a radial pattern. The fuel mixes well with the air as a result.
What are the merits of the direct injection type?
1. The simple structure and heat efficiency allow for low fuel consumption. 2. The small surface area of the combustion chamber keeps heat from escaping, so there is little heat loss. 3. Thus, there is good startability.
What are the demerits of the direct injection type?
The demerits are: 1. The injection pump is high performance, and highly accurate multi-holed nozzles are used. Thus, it is costly. 2. It is sensitive to changes in fuel and operating conditions. 3. Diesel knock is more likely than in other types of engines. Direct injection diesel engines are widely used in all sizes of trucks because of their fuel economy and high power. Let's move on.
Yes.
In the pre-combustion chamber type, there is a small pre-combustion chamber in addition to the main combustion chamber. Fuel is injected into this small chamber. This fuel partially combusts there, increasing the pressure. This pressure pushes the remaining fuel into the main combustion chamber with intense force, where it mixes with the air and completely combusts.
What are the merits of the pre-combustion chamber type?
1. Low pressure from the fuel injection pump is sufficient, so the nozzles can be simple. 2. Fuel mixes well with air, so there is little diesel knock. Operation is quiet, and exhaust emissions are low.
Are there any demerits of the pre-combustion chamber type?
Yes, there are. 1. They are structurally complex. 2. Fuel efficiency is lower than with direct injection. 3. The larger surface area allows more heat to escape, so they are difficult to start. A glow plug is necessary to heat the pre-combustion chamber initially. Because of these demerits, they are less economical, and thus used less and less these days. Do you understand?
Yes.
The swirl chamber type is next.
In its makeup, the swirl chamber type is between the direct injection type and the pre-combustion chamber type. The shape of the swirl chamber, which is larger than the pre-combustion chamber, promotes air to swirl intensely during the compression stroke. Fuel is injected into this chamber and mixes well with swirling air, largely combusting immediately. The defining characteristic of this type is the fast combustion speed.
What are the merits of the swirl chamber?
The merits are: 1. High combustion speeds permit high engine speeds and allow engines to run smoothly at a wide range of speeds. 2. Just as with the pre-combustion chamber type, low pressure from the fuel injection pump is sufficient. So the nozzles can be simple. 3. It runs relatively quietly and has low exhaust emissions.
What about the demerits of the swirl chamber?
Just as with the pre-combustion chamber type. 1. They are structurally complex. 2. A glow plug is necessary to start it up. These are demerits, but this type is commonly used in the city in small trucks and passenger cars that need to make tight turns.
Professor, I'd like to see the inside of an engine.
All right. I'll teach about the engine's interior with a cross-section model. This is a rather old engine, but the basic operations don't change, so I'll use this to explain. This part is the cylinder, and this is the piston. This entire area is called the crankcase. I'll explain something here. In gasoline engines and some small diesel engines, the cylinders are holes in the case itself. In most diesel engines, however, there is a tube inserted called a cylinder liner or a cylinder sleeve.
Professor, this is the piston, right? So what's this?
These rings around the head of the piston are piston rings.
What's this below the piston?
This is the connecting rod. It connects the piston and the crankshaft and switches the pumping motion of the piston into the revolving of the crankshaft.
Then the connecting rod has to be really strong, right?
Right. So let's turn it on. Switch on. The piston's movements are linked to the crankshaft, like you see here. Understand?
Yes.
Okay, I'll turn it off.
Okay, Professor, what's this?
This is the intake valve. The smaller one here is the exhaust valve. This area is the combustion chamber. This is the intake port. This is the exhaust port where exhaust leaves. This part covering the valves is called the cylinder head. Gasket plates are tightly affixed between the cylinder head and the crankcase as packing to prevent gas, oil, or water from leaking. Did you get all of that?
Professor, which of the last 3 types of engines that we learned about is this one?
This is a pre-combustion chamber type engine. Now, let's look over here. This is the pre-combustion chamber. This is the injection nozzle, and the glow plug to start the engine is right here. Got it?
I understand completely. Professor, let's turn on this cross-section model again.
Okay, I'll turn it on again. Watch carefully and pay attention to the operational sequence of intake stroke, compression stroke, power stroke, and exhaust stroke. Switch on! Now, please look at these. These are the pistons that I was talking about earlier. Did you know there are 3 rings on the piston? I'll explain their role with an illustration. The top 2 rings are called compression rings, They form an airproof seal. The bottom one is the oil ring. Its role is to scrape off excess oil. This one has 3 rings, but some have 4. Like this one.
Professor, a message has arrived that says, please explain the turbocharger.
All right then. I'll explain the turbocharger.
The turbocharger is a device that boosts engine performance, right?
That's right. The turbocharger boosts the engine's power without increasing the exhaust. To increase power, the cylinder's diameter and the piston's stroke are changed, increasing the exhaust volume. But doing this causes a problem. What do you think that is?
If you increase the exhaust volume, wouldn't you have to make the engine bigger?
Exactly. But we can't increase the engine size too much. If we just increase the amount of air, then much more fuel can be burned. The turbocharger uses this turbocharging principle.
In a turbocharger, the force of the engine's exhaust gases is used to turn the turbine wheel, which turns the compressor wheel, sending in large quantities of air.
So this turbocharger can increase the engine power.
Right. This is an actual turbocharger here, and this is a cross-section model. I'll explain using the model. Exhaust gases enter here and go this way. This spins the turbine at incredible speeds, as high as 100,000 rotations per minute. Large amounts of compressed air flow into the engine, allowing more fuel to be injected and burned. Thus, with the same amount of exhaust, the engine power is increased by 20 to 50%.
That's impressive.
Isn't it? There, that should give you a basic understanding of diesel engines. You shouldn't have any trouble with mechanically savvy customers now. I'd like you to handle them with confidence.
Wow!
All these messages came for me while I was out.
So
Just
many.
cleaning those up will be difficult. Oh.
What happened?
I ran out of gas. I heard that after I fill up the tank again, I need to bleed the air out to start it. But I don't know how to bleed the air out.
Yes, bleeding the air. Please wait a moment. I'll go and ask.
What's wrong? I don't have time for this. Well?
Well,
Now what'll I do? I'd better explain in more detail about the engine, centering around the fuel injection mechanism so this doesn't happen to you. First is the fuel injection mechanism. So let's look at the way fuel flows through the engine.
fuel is sent by the feed pump from the fuel tank to the fuel filter. Then water and debris are filtered out and the fuel enters the injection pump, where it is pressurized and sprayed out of the top of the nozzle. This is the flow of fuel through the fuel system. The injection pump plays the most important role in the fuel system.
Okay, a demonstration. Here it is.
Huh? Isn't that a syringe?
Indeed it is. The injection pump functions on the same principle as this syringe. It takes the fuel in like this, and then sprays it out under pressure. The basic idea is just like that. The difference is that the injection pump is made up of various sophisticated elements.
I see. So it is similar to a syringe.
There are two types of injection pumps. The inline type, which contains an individual syringe for each cylinder, and the distributor type, which uses one syringe to supply fuel to all the cylinders. Most trucks use the inline type. The distributor type is only used in some small diesel engine vehicles. Understand?
Yes.
As the plunger moves downward, fuel from the tank is drawn into the plunger barrel through the fuel in-out port. The motion of the cam makes the plunger move upward, closing the fuel in-out port, pushing the fuel out into the injection pipe where it is sprayed out of the nozzle. As the plunger rises further and a diagonal hole called the plunger lead meets the fuel in-out port, the remaining fuel is pushed through, returning to the fuel tank and ending the fuel feed. A collar protruding from the bottom of the plunger meshes with the control sleeve that covers the barrel. In this way, the linear movement of the control rack causes the plunger to rotate.
I see. So the control rack's movement causes the plunger to rotate.
That's right. But between the control rack and the acceleration pedal, there's an ingenious control mechanism. We'll talk about that later.
Okay, got it.
Let's see. We've learned a lot already, so you probably already know what happens when air gets into the fuel. Right?
Yes.
Watch this.
When the fuel tank becomes empty, air is sucked into the pipe. Fuel added later will sandwich in the air bubble, pushing it into the pump. The pump just pushes air out, so the fuel won't be able to pass through and the engine won't start.
Professor, not being able to start the engine is a real problem.
Indeed it is. Once you run out of gas, you need to let the air out before you refill the tank.
I see. That's called bleeding the air, right?
Right. Since you need to know how to bleed the air, let's see how to bleed the air out from a small vehicle's engine.
Loosen the air bleed plug on the fuel filter. Place a cloth over the air bleed plug and repeatedly push the hand pump until fuel without air bubbles comes out. When the air bubbles are completely gone, tightly close the air bleed plug. Keep screwing it in until the hand pump is tight. After bleeding the air, wipe all spilled fuel off and start the engine.
Remember that I said there's another mechanism to move the control rack besides the acceleration pedal? That's the governor. It's a bit complex, but when you get into selling specially equipped vehicles, you'll need to understand it. I'll just explain the basic principles to you.
The governor?
Yes.
What does the governor do?
Oh, another question. Well, I guess I can explain with this model. When idling, only a little fuel is being injected and makes it difficult for the engine speed to remain stable. Pressing the accelerator pedal can increase the engine speed too much and could break it. The governor prevents these problems. It is designed to keep the engine speed within a certain range, even if the load or the speed changes.
Are there many types of governors?
Oh, yes, there are many types of governors.
Pressing the accelerator pedal causes the control rack to move in the fuel increase direction, increasing engine speed. Generally, the accelerator pedal controls the engine by moving the control rack. However, when the engine rises to near its maximum speed, the centrifugal force of the flyweights moves the shifter to the right, the direction of fuel reduction, slowing the engine speed even if the accelerator pedal is pressed. This is how the mechanical governor keeps the engine speed within a set range automatically. At present, the electric governor is much more common. In an electric governor, a computer determines the optimal fuel injection amount based on the engine speed, engine loading, and coolant temperature. Recently, Mitsubishi Fuso has adopted computer-controlled common rail fuel injection systems to reduce nitrogen oxide and PM emissions while optimizing combustion. This controls the number of injections per cycle, the timing of injections, and the amount of fuel injected to realize an ideal of the entire range of engine speeds. The ECU runs a self-diagnostic to check the primary components. If there are any irregularities, the driver is notified via the diagnosis and alarm functions. The intake and exhaust systems are important auxiliary systems. The systems that bring air necessary for combustion from outside and then send the exhaust gases out are collectively called the intake-exhaust system. Let's see how the intake system works. Air is taken from a place with relatively clean, cool air, cleaned in the air cleaner, and proceeds through the intake pipe to the intake manifold where it is sent to each cylinder. Next, let's see how the exhaust system works. Combusted gases enter the exhaust manifold and proceed down the exhaust pipe where they are silenced in the muffler before exiting the tailpipe.
Oh, I should tell you about a turbocharger that utilizes the exhaust. The turbocharger compresses air and sends it to the cylinders. However, compressed air increases the temperature while decreasing the density. So recently, intercoolers have been adopted to lower the temperature. Okay?
That's called a turbocharged intercooler, right?
Right. I'm jumping around a bit here, but moving vehicles need to be able to stop, right?
Especially high-powered large trucks. They need high-performance brakes.
Exactly. Ingenuity is required for the brakes as well. The exhaust brake, which uses the exhaust system, is regarded as so essential in trucks and buses that it is almost standard issue. I'd better explain this in detail. Then come this way. You know that releasing the accelerator pedal will engage the engine brake, right?
Yes.
Pressing the accelerator pedal turns over the engine, which makes the wheels turn. Releasing the accelerator pedal makes the engine try to idle. But the force of the moving vehicle tries to turn the engine. The engine's resistance thus reduces the vehicle's speed. This is engine braking. The exhaust brake basically increases the performance of the engine brake.
Yes.
Flipping the exhaust brake switch moves the exhaust brake valve and covers the exhaust manifold's exit. This traps the exhaust gases, increasing pressure in the cylinder and improving the effectiveness of the engine brake. This is the basis of the exhaust brake.
Finally, lubricating oil and coolant are necessary for the engine to run smoothly. I'll briefly explain how they work. This is the oil line.
Oil circulates all over the engine.
That's right. You know that if the oil runs out, the engine will burn. But I want you to remember that the quality of the oil is really important in diesel engines.
Why is that?
Compared to gasoline engines, diesel engines operate under extremely harsh conditions. The oil burns easily, so special attention needs to be given to oil quality and day-to-day upkeep. Do you understand?
Yes, I've got it.
Specific oil is made for Mitsubishi Fuso engines, so please use the designated oil.
Next is engine coolant.
Engines really need to cool off.
Oh, you are mistaken. Engines won't perform well if they're too cold. Humans are the same way.
That's right. We do warm-ups before exercise.
Ah, it's just like that. There's also a thermostat installed, so that when you start the car, the coolant doesn't go to the radiator until it heats up.
So the coolant doesn't circulate until the engine heats up.
That's right. The thermostat is here. Another cooling device, the cooling fan, is here. Normally, the cooling fan is powered by the fan belt, which the engine powers while it's on. But actually, the fan isn't necessary when starting the car or when it's cold outside. Most trucks use an auto cooling fan, which only turns on the fan when it's needed.
A thermostat is installed on the center front of the auto cooling fan. When the air passing from the radiator goes above a certain temperature, it activates the fan.
Here are the merits of the auto cooling fan. 1. The fan doesn't operate when it isn't needed, conserving power and reducing fuel waste. 2. Noise is reduced, as the fan doesn't operate unnecessarily. 3. Prevents the engine from being overcooled, extending engine life.
I see. There are many merits.
Indeed. Now you have learned how to deal with mechanically savvy customers. Now you have all the knowledge that you'll need.
I think I understand better now.
Yes, deal with your customers confidently.